Okay, so as I mentioned, typically in high school anyways, both grade 11 and grade 12, we use phenolphthalein as a pH indicator, simply because it's the easiest to see the endpoint of. So when it's in an acid, it is colorless. So here's what it looks like. When it's in a base, it's a dark pink. So the end point that you're looking for to say that we have neutralization or we've reached basically equivalence point should be a very, very, very light pink. Like as soon as this becomes a pink color, this is overshot. Okay, you don't want to see this dark. So this dark pink. So as soon as you see this, you would stop adding your titrant, and then of course you would measure the volume of that. So let's take a look at some calculations. So obviously once we have our volume, we can now determine, the whole purpose of this lab, right, is to determine the unknown concentration. So let's take a look. So in an experiment, we have 25 milliliters of sulfuric acid with an unknown concentration. So this is what we want the concentration of. We're titrating it with a 0.125 mole per liter solution of NaOH. Use the data below to calculate the concentration. So we're told the initial burette and the final burette reading. So the volume of NaOH, so the change in volume is always final minus the initial. Okay, that goes for any, and change in anything, change in temperature, change in whatever. So in this case, it's going to be 15.2 milliliters minus 0.4. Right, so we get a total volume change of 14.8 milliliters. So this is how much, what does this number mean? This is how many drops, what the volume was that they had to add until they reached that end point where they saw the color change. So when you're doing this part here, this is now basically stoichiometry. Exactly the same that you were doing before. The only difference is now it's an acid-base reaction. Same deal though. We have some information. We're missing some information. So we always start off as usual with our balanced chemical reaction. So we have sulfuric acid reacting with NaOH. And that's going to make water and sodium sulfate. And this is AQ. Okay, so once this is balanced, we need a 2 here and a 2 here. Okay, so let's write down what we have. So the concentration of sulfuric acid is what we don't know. We have the concentration of NaOH. We have 0.125 moles per liter. And we have the volume of NaOH because that's what was inside our burette, so which is 14.8 milliliters. Now, because we're going to be using stoichiometry and this is moles per liter, we know this has to be liters. So we might as well do that right now. Okay, so the volume, we're missing concentration here and we're told that we had 25 milliliters of it. So we have the volume. So again, we know we need this in liters eventually. We might as well do that. Okay, so here we go, regular stoichiometry. We have C and V. We're going to find moles here. So moles of NaOH is going to be C times V, 0.125 moles per liter times 0.0148 liters. We have 0.125 times 0.0148. So we have 1.85 times 10 to the negative 3 moles, and that's moles of NaOH. And then we have to set up our mole ratio, right? So we want moles of H2SO4. We have the moles of NaOH. And the ratio is 1 to 2. Right? Okay, so let's solve for our x. So basically it's going to be our 1.85 times 10 to the negative 3 divided by 2. So we get 9.25 times 10 to the negative 4 moles, and that is now for H2SO4. So the last step, now that we have moles, we can solve for C. So the concentration of sulfuric acid is going to be moles per liter, which we have 9.25 times 10 to the negative 4 moles over, so remember we have our volume, 0.025 liters. And we get a concentration of 0.037 moles per liter. And I believe that is 2 sig figs, which is what we need. Now, actually, when you're doing this with your volume amount, there's something I want you to be careful about. So these values here, remember you're doing subtraction. So technically the volume that you're working with is the 14.8 milliliters. Normally when you're doing titration reactions, you only, for sig figs anyways, you look at the original numbers up here, okay? If you forget and you do this, I'm not going to deduct marks, but obviously you have to follow along with some sort of data that you're given here. So in this case, right, 3 sig figs. So actually we'll just tack on a 0. Okay, so give this next one a try. So it's a very similar situation, different reaction. So we have 25 mils of hydrochloric acid with an unknown concentration. We're titrating it with 2 moles per liter of NaOH. And we're given the data from our burette reading. We want to solve for the concentration of HCl. So give this one a try. All right, so let's take a look at this. So you should have gotten here your volume 15 milliliters. All right, so we have our reaction, HCl reacting with NaOH, making water and sodium chloride. Okay, so we have the volume of HCl. I'm just going to go straight to liters since we know we're going to have to do that. Concentration is what we're looking for. The volume of our NaOH, 0.015 liters. Concentration, we're told, is 2.0 moles per liter. Okay, so we're going to find moles of NaOH, C times V, right? So we have 2.0 moles per liter times 0.015 liters. So essentially we have 0.03 moles. All right, let's double check on that, but I'm pretty sure that's that. Yep. And then actually our mole ratio is 1 to 1. So X for HCl over 0.03 NaOH. This is just a 1 to 1 ratio. So actually your X is going to be the same number for HCl. So C is equal to N over V for HCl. So it's going to be 0.03 moles over 0.025 liters. So our answer here should be 1.2 moles per liter, and I believe that is already 2 sig figs. Yes. Okay, so we have 1.2 moles per liter. Now, obviously, this can get more difficult depending on the type of reaction this is. So you really want to make sure that you are comfortable, of course, with writing chemical reactions, but that's like with every case with stoichiometry, right? This is really you have to make sure your reaction is correct in order to get the correct ratio and all that other good stuff.